Hi, my name is Edagel JESUS-NEGRON, and for this project 2, protocol analysis, design and measurement, I'm going to be showing a little bit about the second step of the project, that it is to set up the analyze a protocol developed by the professor and starting the Jupyter. First, I'm gonna start Jupyter right here, the Jupyter notebook. So once it's completely loaded, I'm going to look for the file for the one that it is the stop and that is stop and wait protocol. And once this is open, I'm going to make sure everything is already installed, as you can see right here on this other terminal. And I'm going to be running all the cells. Once everything is running properly, as you can see, I'm not having any errors. If there's an error on any thread, I'm going to be receiving a red box right over here, telling me that it's receiving an error. So I'm going to be submitting from on the ALE to typing on the Alice, which is this one. I'm going to be submitting the text stated in the second step, which is Alice to Bob. Going to be submitting it. And in this other cell, I'm going to be writing Bob to Alice. Once I have this and I send it, I'm going to be showing the different examples of messages that I'm going to be receiving based on how the code was implemented. So, and as you can see, a little bit more to the bottom, the message 0, 1, 2 is going to be shown a little bit more to the bottom to that the message was received. And like here, message received. Here's a successful example of the message being received. Then a scenario where the data frame is lost is going to be something like a packet loss, and it's going to be this example right here. As you can see, the message number 3 was a packet loss. Due to this, it's not going to an example for this other scenario. Then the third example is an acknowledgement for the frame that is lost. So, and if we go a little bit more to the bottom, we can see that it will show us a message about a certain amount of messages that could not be delivered. So let me right here. So received 5 frames but expected 6. So here is the acknowledgement from where the frame is lost. So this concludes the second part of the project. So thank you very much once again, and see you on the next part. Okay, so now for the third part, which is stated to emulate a different physical layer. We have to revise the loop tx function from the PLE-TR class, which is this one right here. This one. We have to change the code to the transmission so that the probability to be lost is 10%. So it would be this one. Change the probability to 10%. And also the probability of being duplicated to 0.0, basically 5%. So here is the code added for that. And also we have to revise the loop Rx function so that the delay would be a random number from 0 seconds to 2 seconds. So here's the code for that. Created a delay variable, which it would be called here from time sleep, to emulate that type of new different physical layer. So right now I restarted the kernel and am going to be submitting the Alice to Bob again, and the Bob to Alice. Oh, sorry. And once this is done, we're going to be receiving similar output actually from what we did before. However, there might be, in terms of the packet duplication, a new message for that. And so this actually will be emulating a more, with the changes made, it's going to be communication more realistically, with the chances of packet loss, the duplication, and the variable delays. So with messages affecting Alice to Bob and Bob to Alice also. And this could be similar in terms of the responses. And for example, like the one with the packet loss and the chances of the duplication. Because Alice prepares and sends the message to the data link, then Alice's data link layer wraps it as a frame and passes it to the physical layer, and there should be no loss in terms of a successful transmission. And the processes of an acknowledgement back to Bob will pass the processes and frames acknowledges back to Alice, confirming that it was successfully delivered. So in terms of data frame loss, it would be when the Alice PLE sends a frame to Bob, but in this case it will have a 10% chance of not reaching the Bob's PLE. So this Alice DLE will wait for a certain timeout for an acknowledgement. When there is no acknowledgement, it will come back as Alice's DLE resends the lost frame. This will create a delay in the transmission, and Alice will ultimately ensure delivery. And in terms of acknowledgement loss, Bob will receive Alice's message. Let me see if I can find an example here. We'll send Alice's message and sends an acknowledgement. Now with a 5% chance of that it won't reach to the packet loss or duplication. When Alice's DLE does not receive this acknowledgement in time, it will resend the message. But Bob DLE will detect it as a duplicate frame and resends the acknowledgement back to Alice's, which will finalize this transmission without sending duplicate messages of the application layer. So let me see if I can find an example of the duplication. Right here, it will be another packet loss and packet loss, and here, right now, here we have a packet duplication example, fulfilling basically all the examples for this third step. We'll continue with the fourth step later. Thank you. Hi again. Here we are right now for the fourth part of the project. So it says here to make a new class called MLETR. So here's the new class called MLETR. Here I added a few things to reinitialize the physical layer entities, initialize the existing classes, and I had a few problems with trying to import some things, so I re-imported again all the everything, and I set the global thread control, initialize them all over again. So here we're going to be calling 100 messages. So we have here in the four that we're making the 100 messages. We are going to be showing also the time. So here we are going to be converting it to milliseconds by calling the lower layer interface and showing the different types of messages. So here we're going to be sending all that data in the message, and also we're going to be doing a loop to show the average delay, and that is here the delay, the average delays also, and the loss rate and the duplication rate. And here in my code, it's once you run all the cells again, you go and it will show the to the start experiment. Here I made a comment because I added the function here at the bottom to make the analyze and the results. For the test that I did, I actually got everything almost instant, and that is my results for the experiment and for the fourth section. Thank you very much.